Hello everyone, welcome back to my channel. So in this video we are going to solve one practical problem using numerical integration method. So one of the numerical integration method, which is Simpson's 1/3 rule. Okay, so if you are first time to my channel, please consider subscribing. And I have already explained you about Simpson's rule in one of my video, so I am giving the description, so in the playlist link in the description, so you can see there, go there and see all the topics which I have discussed using Simpson's rule, and then come back here to solve this problem. Right, in this problem he has given that a train is moving at 30 meters per second. So when the train is moving at 30 meters per second, the steam is shut off and the brakes are applied. That means you are stopping the train. Okay, so when train is moving at 30 meters per second, you are stopping the train, and train cannot stop instantly. Okay, so train cannot stop instantly, so it travels for 40 seconds even after application of brake. Okay, so if you observe here at time t, it is moving at 30 meters per second, so there brakes are being applied, and then for each and every 5 seconds the speed is given for you. So if you observe here, the speed is going to decrease from time to time, right? So from time to time the speed is going to decrease. Why? Because brakes are applied and steam is shut off. Okay, so he is asking to find the distance traveled by the train. Okay, so distance traveled by the train in 40 seconds. That means in these 40 seconds, even after applying brakes, how many meters the train has traveled, he is asking us to find. Okay, so when there are changes in speed changing and time is also changing, so we know that speed is equal to distance by time. Okay, so v is equal to ds by dt. Okay, so speed is equal to distance by time. So now we are going to calculate for distance. So we are going to calculate for distance. So s can be written as s is equal to, so ds, if you take this ds, send this dt that side, so you get v into dt. So if you integrate over, so you'll get s is equal to integral v dt, integral v dt. Okay, so the time here, because the integration is with respect to t. Okay, so the integration is with respect to t, right? So when integration is with respect to t, so you have to take the values of t. So values of t, that is the limits of t, is from 0 to 40, so it will be 0 to 40. Okay, I'm sending this differentiation d is there, ds is there, so I'm sending this differentiation to the right hand side, so it will become integral. So integral, so differentiation coming this side, it will become integral. So is integral 0 to 40 v dt. So v dt I have not changed, only with respect to this s. Okay, so sending this differentiation this side, it become integration. So now the integration is with respect to t, we have to take the values of t, that is t is ranging from 0 to 40. So this is the value of s. So this integral we have to find now. Okay, so this integral we have to find. So in order to find this integral, they are given with all the values. Okay, so this 30 is our y naught now. Suppose if you are finding v, so it will take it as v naught instead of y naught. I will taking v naught. This will be v1, this will be v2, this is v3, this is v4, this is v5, this is v6, this will be v7, and this will be v8. Okay, so s is equal to, okay, so using Simpson's 1/3 rule, Simpson's 1/3 rule is h by 3, right? H by 3. So what is h value here? So increment here is 5 and increment here is also 5, so the step size is 5. Step size is 5. Okay, so h by 3 into v naught plus v8. v0 plus v8. So this first value and the last value, because integral, so inside the function is only v, so we'll take directly the values v0 plus v8 plus 4 into the odd values. Odd values are v1 plus v3 plus v5 plus v7 plus 2 into even values. Even values are v2, v4, v6. So v8 is already included, so you should not include here. Okay, so this is the answer. So that is what you have to find here. So what is h by 3? H is 5, so it is 5 by 3 into v0 plus v8, it is 30 plus 7. 30 plus 7 plus 4 into v1, 24 plus v3. v3 is 16 plus 11.7 plus 8.5 plus 2 into v2. v2 is 19.5 plus 13.6 plus v6 is 10. Okay, so solve using your calci, you will get around 606.66 meters. Okay, so this is the distance traveled by the train even after the application of your brakes. Okay, so this is how we can solve any problem using numerical integration. So this is the practical way of solving a problem. Okay, so you'll get you may get problems like this in many competitive exams also, like GATE. Okay, so next we'll see one more problem on this. Okay, so one more practical problem on this. So a rocket is launched from ground and its acceleration is measured for every 5 seconds and is tabulated as below, like this. Okay, so you're asked to find the velocity and the position of rocket after 40 seconds. Okay, so the position of rocket and the velocity of the rocket, okay, after 40 seconds you are asking to find using trapezoidal rule. Okay, so same, what is acceleration? So we know that acceleration is rate of change of velocity. Okay, so rate of change of velocity is acceleration. Okay, so this is from normal physics formula, right? So what is v then, or dv first? dv is equal to a into dt. So send this differentiation that side, so what you will get, v is equal to integral a dt. Now the limits, integration is with respect to t, so limits of t is from 0 to 40, so you'll get 0 to 40 like this. Okay, so if you solve for this integral, you'll get the value of velocity. Okay, so once you get the velocity, you can find the position. Okay, so this is your a0, a1, a2, a3, a4, this is a5, a6, a7 and a8. Okay, so using trapezoidal rule only, so v is equal to h by 2. So h is now the step size is still 5, so 5 by 2 into a0 plus a8, a0 plus a8 plus 2 into remaining a1, a2, a3, a4, a5, a6 and a7. Okay, so 5 by 2 into a0 plus a8, so it will be 40 plus 68.7 plus 2 into a1 value is 45.25, a2 is 48.5, a3 is 51.25, a4 is 54.35, a5 is 59.48, a6 is 61.5, a7 is 64.3. Okay, so if you solve using your calci, you'll get 2194.9 meters per second. This is your velocity because acceleration is given in meter per second square. So this is your velocity. Okay, so this is the speed at which the average speed at which this is traveling, that is rocket is traveling for 40 seconds. Okay, so if this is your average speed, then what will be the position? Then what will be its position? So per second, on an average per second, the rocket is traveling these meters, that is 2194.9 meters for every second. Then after 40 seconds, so what will be its position? That is what will be its position from the ground. So a rocket is traveling from ground to a certain value, so this position we have to find. So this distance you have to find after 40 seconds. So this is at 0 seconds. At 0 seconds it started from ground and reached to some point after 40 seconds. This position you have to find. That means the distance you have to find, the distance traveled by the rocket for 40 seconds you have to find. That is called the position. Okay, so we have found the average velocity, traveled by this for each and every second. So after 40 seconds means it will be 2194.9 multiplied by 40. For each second it is 2194.9 meters. Then for 40 seconds it will be 2194.9 multiplied by 40. So it will be 87796 meters. So rocket is at 87796 meters from the ground after 40 seconds. Okay, so this is how we can find the position of the rocket after certain time, right? So this is how we can find the problems, that is practical problems, using your trapezoidal rule. That is, you can use trapezoidal rule in this problem. So you can use Simpson's 1/3 rule in the same problem, or you can also use Simpson's 3/8 rule also. So almost all the results will be same, right?